So I went ahead and took the liberty of doing a flipbook of this. And you can see it's explosive now, as opposed to what we were dealing with before, was this kind of slow, meandering thing. I mean, there's a time and place for this. I mean, you know, we would improve this anyway, but in terms of the speed and shape, yeah, there's a time and place for this, but what we were doing here is an explosion. So, pop. And you can see how interesting the shape is because of the tendrils. The tendrils, that's not something you would ever be able to get from a sphere. So, particles are the way to go. Now, part of the thing that we got from particles, is the velocity. We can use that too. Now, I don't want to have the velocity influence this too much, but I would still say, I mean, it does exist. They do have velocities. Of course, they're from particles after all. So let's just, for completeness, say copy and paste our volume rasterized attributes. Let's move this here. And this will, instead of being the temperature burn one, we'll say this can be the V velocity one. You know, the visualization doesn't really make sense when we're talking about velocity here, but we can, or at least the visualization as smoke doesn't make sense. But we can do a volume slice, which makes us I don't even see anything. I'm just going to move it a little bit. Here we go. We've got RGB representing the X, Y, and Z of the velocity, and we'll do a volume trail so we can advect those points through the set velocity field, and we end up with some nice little visualization here. And that is it. I mean, that is the velocity of the points. We could do something, we could say the particle scale is 4 if we wanted to have it exist in a little wider radius around it, just to add it a little bit more life. I mean, we're not going to see that much from this either way, but for the sake of argument, I'm going to say point velocity, put it here. Point velocity right now is trying to figure its own stuff out and is running into problems. Let's just say keep incoming. We already have a velocity. Curl noise, add curl noise. So in this way, I'm just going to add a little bit of fun, you know, literally curliness to this thing. I'll even maybe go a little bit more. So now I have a more turbulent velocity that we're going to add in. And that's about it for that. I'll just merge it in. Oops. And once we merge it into our source here, we'll need to update our volume source in the sim. I'll do that over here. And say, just put a plus anywhere and say the source volume is V because that's the name of the volume that we made. But it's called vel in the pyrosim. Pull is probably the right thing to use here. I'm going to put add because it's going to be so small anyway. Let's just see. They'll probably look virtually identical. Oh, I forgot to go back to the first frame, but I will. So we end up with, actually it's super lumpy now. We're adding way too much velocity in after all. I only want a little bit of it. I mean, most of the shape that we're getting, we're already getting from the velocity, from the buoyancy from the divergence of the explosive velocity. Any more velocity that's coming in from the particles really would probably be overtaken by the actual explosive nature of what's going on here. So I'm just going to do a little bit of velocity on top. Good enough.